If the max force a cat's bones can take before breaking is 404.31 newtons and mass of the cat is 3.78 kilograms, using A equals F over M, what is the minimum stopping distance required for the cat to be unharmed after falling for 1.75 seconds, assuming constant acceleration? We want to set up two position functions, one for before the fall and one for after. We'll call the first one y sub 1, and it follows the basic physics equation for position: initial position plus initial velocity times time minus 1/2 at squared. We want to find the initial height. We can rearrange and plug in acceleration, negative 9.81 for gravity, and 1.75 for time. To find its initial height was 15.02 meters. Next, we want to find the velocity right before impact with the flag. We'll find that by taking the derivative of the position equation, which is negative gt, plugging in negative 9.81 for g and 1.75 for t. We find that the velocity right before impact is negative 17.1675. Next, we want to find the max safe acceleration for the cat to not break its bones. We will divide 404.31 newtons by 3.78 kilograms. Putting this into the calculator, we get 106.96 meters per second squared. With all of these values, we can now find the stopping distance, setting up the second equation to represent the position after contact is made with the flag. We'll subtract t fall so that the equation starts where the last one ended. So y sub 2 equals y sub 1 of t fall plus velocity at impact times t minus t fall minus 1/2 acceleration, the stopping acceleration, times t minus t fall. And this equation is coming from the position equation. Y sub 1 of t fall is going to be 0, since we're evaluating it at 1.75 seconds, and previously we said that that will be when it touches the flag. It follows the simple physics equation that we've been using of position: initial plus initial times time minus 1/2 at squared. We can reduce the equation and plug in our numbers. So y sub 2 equals negative 17.1675 times t minus 1.75 minus 1/2. A is 106.96 meters per second squared times t minus 1.75. Now that we have the position equation, since we want to know the minimum stopping distance, we want to find the extrema of the second position function. We'll start this by finding the derivative of the equation. This is 13,461 over 80 minus 2,649 over 25 t. Setting this equation equal to 0, we find the time at where the maximum, the extrema for this function. It's at 1.58. Plugging this value back into the position function will result in the minimum stopping distance required for the cat to be unharmed. Plugging this into the original equation, we get a value of 1.37 meters.